Okay, Wildcats, today we're looking at Friday, January 26th, solving square root inequalities on page 49. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, square root inequalities on page 49. Solving square root inequality steps. Step 1, isolate the square root. Step 2, raise both sides of the equation to the power of 2. Step 3, simplify and solve. All right, now let's look at steps 4 through 6. Step 4. Now this is where it gets different than solving an equation. You have to consider the radicand, okay? The radicand must be greater than or equal to 0. So you have to take in consideration of that. So not only do you have to solve, but you also have to solve the radicand greater than or equal to 0. And then step 5, graph the solution. Step 6, state the solution. All right, finish up your notes. All right, now your notes are updated. Let's take a look at the examples. All right, example 1, solve each inequality. All right, so it says step 1, isolate the square root. The square root's isolated. So now we're going to square both sides. Okay, the square and square root become power of 1, so that's 2x plus 4 less than or equal to 16. Okay, you're going to subtract 4 from both sides, so you get 2x less than or equal to 12. Divide 2 by both sides, x is less than or equal to 6. All right, now you have to take into consideration the radicand. Okay, and I actually want you to write radicand, so I know that you're solving for the radicand. Okay, it's also a good way to remind yourself that you're solving for that. So you set 2x plus 4 greater than or equal to 0. So you subtract 4 from both sides, so you get 2x greater than or equal to negative 4. Divide 2 by both sides, so then x is greater than or equal to negative 2. So now we graph the solution. So we have negative 2. It's line underneath, so it's a closed circle. And it says it's greater than the negative 2. So on my first shade, I'm going to shade light because you're looking for the overlapping region. Okay. Now we're at 6. Again, closed circle because there's a line underneath. And then you're looking for less than or equal to 6. So that's here. Now I'm going to darken where it overlaps. Now technically it goes past this point, but this is the solution is the region where the shading overlaps. So then we state the solution. So x is less than or equal to 6 and greater than or equal to negative 2. All right, let's look at example 2. All right, we want to isolate the square root first. So we're going to subtract 3 from both sides. So we get the square root of 2x minus 6 is less than 6. Then you square both sides. That becomes the power of 1. 2x minus 6 less than 36. Add 6 to both sides, you get 2x is less than 42. Divide both sides by 2, x is less than 21. All right, and then we have to solve the radicand greater than or equal to 0. So we set 2x minus 6 greater than or equal to 0. We're going to add 6 to both sides. You get 2x greater than or equal to 6. divide both sides by 2, x is greater than or equal to 3. So then we graph the solution. I was going to put a 0 in the middle, but since both numbers are positive, really you should put 0 on the left. So then 3 is a closed circle because there's a line in. It says you're greater than, so we shade. And again, the first time you shade is shade light. And then 21 is an open circle, and we shade less. And so, again, darkening the overlapping region, and that's your solution. So then we can say that x is less than 21, but greater than or equal to 30. All right, now let's move on to examples 3 and 4. All right, example 3. So we want to isolate the square root, so we subtract 3 from both sides. So we get square root of x minus 4 greater than 6. And then we square both sides. That becomes the power of 1. You get x minus 4 greater than 36. Add 4 to both sides, so x is greater than 40. All right, and then you do the radicand greater than or equal to 0. So x minus 4 greater than or equal to 0. So we add 4 to both sides, so x is greater than or equal to 4. Then we graph. Since both numbers are positive, I'm going to put the 0 on the left. So 4, there's line, so it's closed circle. That's greater than, so we shade to the right. And again, we shade light. And then 40, there's no line, so it's an open circle. And here's where it's unique. Remember, that you shade only the overlapping region. Well, since it's greater than, you darken here. So technically, your solution is x is greater than 40. All right, let's look at example 4. All right, we isolate the square roots, already isolated, so then we square both sides. So that becomes the power of 1, so then it's 2x minus 7 greater than 90 squared. Which is 8,100. So then we add 7 to both sides, so you get 2x greater than 8,107. Then you divide by 2, x is 4,053.5. All right, and then forget about the radicand. Okay, so you set 2x minus 7 greater than or equal to 0. So then you add 7 to both sides, you get 2x greater than or equal to 7. Divide both sides by 2, x is greater than or equal to 3.5. And then you graph. Since both numbers are positive, I'm going to put the 0 on the left. So we'll start with 3.5. So line these, so it's closed circle. That's greater than, so we shade to the right. And then 4,053 0.5. Open circle, because there's no line underneath. We shade to the right. So again, we only shade the overlapping region. So x is greater than 4053.5. All right, let's do the last example. All right, so we isolate the square root, so we add 6 to both sides, so we get the square root of 2x is less than 6. Square both sides. Goes to power 1, you get 2x less than 36. Divide both sides by 2, x is less than 18. And then we do the radicand. So we set 2x greater than or equal to 0. Divide both sides by 2, x is greater than or equal to 0. All right, now we graph. So then 0 is a closed circle. So we shade, and it's greater than, so we shade to the right. And then 18 is an open circle. It's less than, so we shade to the left. And we shade only the overlapping region. So our solution is x is less than 18, but greater than or equal to 0. All right, so at this point, if you had questions on the examples, I can explain those in class. But if you understood all examples, you can start working on the assignment. So you decide at this point what you want to do. Do you want to wait for class, or do you want to start working on the assignment? Either way, have a wonderful Wildcat